Okie dokie, artichokes. So I'm going to kind of show you how you do option number 3. So first off, I'm just going to be following along with that doc that you have online. So make sure that you read through the background information there. You might even watch that video that I posted a link to because it is very helpful. Read through that helpful vocabulary so that way you kind of know what I'm talking about here. And then starting at the materials, that's kind of what I'm going to show you. Okay, so you're going to need 2 crackers. You can use any cracker. You could use graham crackers or saltines or even cracker-like foods like chips. I happen to have some old kind of stale saltines in my cabinet in my kitchen. You're going to need a spoonful of Cool Whip or frosting, but you can use any material that is similar in texture like mayonnaise, salad dressing, yogurt. You could even use jelly. Okay, I'm going to be using mayonnaise because that's what I have on hand. And then you're going to need a half a slice of bread cut into 2 pieces. So what that's really going to look like is a 1/4 piece of bread. So cut your bread in half. I would suggest maybe using the heel if you don't like the heel of your bread. Okay, and then we're going to cut it in half again so that way we have just 2 kind of 1/4 squares. Okay, and then you're going to need I have foil or some kind of plate or something to keep your working area clean so that way your family doesn't get upset with you because you trashed the kitchen. Okay, so the first thing that we are going to do is we are going to put a little dollop of our Cool Whip-like substance here in the middle of our work area. It doesn't have to be super big, maybe just like a tablespoon or so of it. You're going to kind of spread it out just a little bit. Okay, something kind of like that. And then for the procedures, there's actually multiple procedures that you're going to be doing. You're going to be doing 4 different things. So the first one that we're going to simulate is seafloor spreading, which is actually a divergent boundary where the 2 plates are going apart. They're pulling apart. So we already spread out our Cool Whip-like material, and then we're going to lay 2 pieces of our crackers, or both of our crackers, side by side. And it says that to imitate seafloor spreading, we're going to press down lightly on the crackers as we slowly push down and apart in opposite directions, but we're not going to push them more than 1 centimeter apart. So you push down and out. Okay? And I don't know if you can really see what happened right there, but we see that the Cool Whip, it looks like there's kind of this like ridge or this mountainous area right here. And that Cool Whip material, it is representing Earth's magma. Okay, so here we see 2 plates spreading apart. We see magma has come up in the middle and it has kind of tapered out at the edges. And we see this in areas where 2 plates are diverging, such as in the Atlantic Ocean. This would be like the Mid-Atlantic Ridge, okay? So there's our first procedure for seafloor spreading, a divergent boundary. Then our next procedure is for a convergent boundary, oceanic and continental crust. So right here, we're showing this is 2 oceanic plates right here. Okay, but now we're going to show a convergent boundary, so coming together of oceanic and continental crust. So I'm going to take off one of my oceanic crusts, and I'm going to use my bread to represent my continental crust. And the reason why we do this, guys, is because this bread, it weighs about the same amount as the cracker, but it is a lot thicker, okay? It's a lot less dense, and that represents how continental crust isn't very dense, but ocean crust is super dense because it has a lot of water on top of it, crushing it down, okay? So we lay our whole cracker down, and then we also are going to lay our bread down. End to end, we're going to be pushing these together, okay? So we push them together, okay? There might be some friction there, and then you see that the cracker dives under, or it subducts under the bread. So the oceanic crust is subducted underneath of the continental crust. And that's what we see whenever an oceanic and a continental plate collide, okay, or they converge, all right? So that answers the question, which plate is subducted, but why is it subducted, okay? Think about this. Which one is more dense? That might help you a little bit. And then think about why oceanic crust is more dense, all right? So what is on top of oceanic crust that is crushing it down? Okay. Moving on to the next part. Okay, you are going to simulate now continental and continental crust. So get your oceanic crust out of there. Get that cracker out of there. And then you are going to be using your 2 slices of bread, or 2 pieces of bread. You're going to be pushing them together because they are converging. Your 2 pieces of continental crust are converging. Okay, so we're going to push them together, and we see maybe one went under, but we see this really big, it kind of rises up right here. Okay, if I did this maybe a little bit better, you'd see a little bit better. But there's quite a bit of rising up of the bread right here. Okay, so that's what happens whenever 2 continental plates collide. Okay, notice how one doesn't really subduct like whenever we had the oceanic plate in there. Both of them kind of go up a little bit. Okay, so on Earth, this rising of the crust, you are supposed to answer in your lab what landform that would represent. Okay, I'm going to leave that up to you. The next one that we want to show is transform boundaries. And we are going to do this by putting our crackers back on here. We want to show this with oceanic crust. Okay. And we are going to be basically moving them like this, okay? But we want to make sure that they are also pushed firmly together. And this is going to show how the sliding action, okay? And it's more like a grinding action. So we might expect that the cracker is going to kind of break apart during this one, okay? That's why I have it last. All right, so we're going to make sure that we push them together and we're going in opposite directions. This is a transform boundary such as we might find in California on the San Andreas Fault. Okay, so push together and okay. So I don't know if you noticed there, but it wasn't super even the whole time. And also I broke my cracker. So this is actually what happens at transform boundaries, such as in places like California along the San Andreas Fault. Okay, it's your job to figure out what natural disaster this action right here would represent. Okay, and that is it for this lab today, guys. If you have any questions, let me know.